Hello friends, my name is Sergio and today we will be learning how to run a FLAC3D GUI in the cloud using Rescale. Since you're watching this video, you probably are already FLAC3D users and are familiar with our industry-leading software which allows users to solve complex geotechnical problems and perform three-dimensional analyses of soil, rock, concrete, structural ground support, and groundwater flow. So, what is Rescale? Rescale is our technology partner which provides a platform for running CAE software in the cloud. Rescale makes it very easy to run engineering analyses. All users need to do is choose the hardware that they wish to run their software on and upload the input files. Let us see what this looks like. First thing we need to do is log in. After we log in, we click on Workstations. Workstations are cloud instances to which we can connect via a web browser and use them just like we would use an ordinary desktop computer. Once we're in the Workstations section of the platform, we click on Create a new workstation and then click again to confirm our intention to create a workstation. We give our workstation a name, for example, Demo Workstation. Now we need to select the software that we will be running, which is FLAC3D. I have FLAC3D interactive workflow right here, as this is the software that I use most often. If you don't see it right away, you can scroll through this list of all software available on Rescale and find it alphabetically. Or you can just use this search tool and start typing FLAC, and you will see it right away. Once we have selected the software, we need to enter licensing information. If you have an ITASCA web license, then you have been provided an ITASCA license password. Enter here an email address associated with your ITASCA license and the ITASCA license password. Is to select the hardware. Through Rescale, you get access to many so-called core types from different cloud service providers, such as AWS, Azure, Google Cloud Platform, and others. And all of these core types are listed here for you to browse. You can look at the properties of the core type and the prices. The prices are in US dollars per core per hour. Let us select Malachite. It is a powerful core type featuring a third-generation Intel Xeon CPU, 16 gigabytes of RAM per core with 64 cores per node. We will be requesting a single node of Malachite. Next step is to upload the input files. Let us try to simulate an impermeable concrete caisson wall with pretensioned tiebacks. This is an example problem from FLAC3D documentation. I'm going to browse for the files and select them. For convenience, I have combined all my input files into a single zip file, but this is not necessary. We could just as well be uploading individual files. Now we are ready to start the workstation. To do so, we simply click the big Submit button and then use this drop-down menu to specify if we would like to limit where the workstation could be accessed from. The workstation will be ready to be used within a few minutes. I'm going to pause the recording and come back when the workstation has booted up. A few minutes later, we can tell that the workstation is ready because we can see this Connect button. Clicking on it opens the workstation in a new browser tab. Let's open it in full screen mode. The workstation is running a CentOS operating system with a GNOME desktop manager. Notice the shortcuts on the desktop corresponding to different ITASCA products. We're going to be using FLAC3D, so we will look for a FLAC3D icon. Here it is, and we will click on it. This opens a FLAC3D GUI. We can click on Open Project and browse for the files that we originally uploaded. The files can be found in /enc/cloud-username/work. The cloud username is usually something cryptic, like uprod_theob. We will open master.dat under Data Files, and we will click the green arrow button at the top of the screen to run the project. Now the software will start crunching numbers. This may take a few minutes. I'm going to pause the recording and come back when the solution is finished. Welcome back! The solution is now done and we can view the results. Let us look at displacement contours. We can compare them with figure 16 from the documentation. Before we can call it a day, we need to make sure that all the results that we need saved get saved. On a Rescale workstation, the default working directory is /anc/cloud-username/work. All files in this directory will automatically be saved to your Rescale cloud files. Let's make sure that our results files are really here. Indeed, you can see that all the saved files and the PNG images are in our working directory. Now let's go back to the Rescale platform and terminate our workstation. It will take a few minutes to shut down the cloud instance. I'm going to pause my recording one more time. We will reconvene once the instance has been shut down and we will look at our results. Welcome back! The workstation is now terminated. We can now click on Results. This takes us to the list of all files that we had in our work directory on the workstation. These are the PNG images that we exported. Some file types, such as images and text files, can be viewed directly on the Rescale platform. The files can also be downloaded to your local hard drive. Hope you have enjoyed our little tutorial. See you next time. Until then, have fun running your simulations.